In this video, I'm going to show you how to recognize linear relationships. Example 1. There are 4 patterns of squares shown below. So you'll see frame 1, frame 2, frame 3, and frame 4. Complete each of the following tables. So frame 1, the perimeter is what? So if I look at the perimeter, it's outside. So I'm going to count them by the line. So there's 1, 2, 3, 4. So it's 4 units. In frame 2, the perimeter is 1, 2, 3, 4, 5, 6, 7, 8. In frame 3, if I were to count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in frame 4, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I should be able to continue this pattern. Let's see what's going up by. It's going from here to here is 4, here to here is 4, here to here is 4. So I mean the next one would be 20. And the next one would be 24. Okay. What we're going to do now is calculate what's called first differences. They're also called finite differences. First differences, you're basically going to subtract from bottom to top. Always bottom to top. Make sure the frame numbers are in order, so the x variable or independent is in order. So you would do 8 minus 4. And that equals to 4. You would do 12 minus 8. That's also equal to 4. 16 minus 12. That's 4. 20 minus 16. Again, always subtract up. And 24 minus 20. So our first differences are all 4. What does this mean? So let's graph this to see what's happening and what that first differences tells us. So frame 1, our perimeter is 4. Color here. Frame 2, perimeter is 8. Frame 3, perimeter is 12. Frame 4, perimeter is 16. Frame 5, perimeter is 20. And frame 6, perimeter is 24. You notice they go up in the straight line. Well, that's because it's going up by 4 each time. So, oops. I have to draw a straight line through all these points. So what's happening is every time you increase by 1, oh, where's my pen? Every time I go over 1, I'm going up by 4. Any point that I go over 1, I'm going up by 4. Okay, that's our first difference. In this case, the first differences are the same. That means that the perimeter increases by 4 each time the frame number increases by 1. So when this is consistent, first differences are the same, our increase is the same, we call this a linear relationship. Let's look at another example. So now we're going to look at area. That was perimeter. So we're looking at the same ones with the frame numbers. 1. So the first frame was same example. So if you think about frame area is just length times width. So it's 1 times 1. So area of a square, just to recap, is length times width. Okay, so it's going to be 1 times 1, which is equal to 1. Okay. The second one is going to be 3, because there's 3 squares in that third frame. Sorry, second frame. So 3 units squared are third frame had 1, 2, 3, 4, 5, 6 squares. So that's going to be 6 units squared. And the fourth one that we had was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's fourth frame. So then we had 10 there. So let's see if we can continue this. So this is 15 and this is 21, and that's given to us. Now let's see if there's any pattern here. So I'm going up by 2's here, but I'm not going up by 2 here. So I'm not adding. So I'm going from 1 to 3. So the pattern is not the same as we're used to. So let's do the first differences to see. Remember, if our first differences are the same, it's got to be linear. Okay, we'll check that by graphing. So I'm going to always subtract up. 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. Oops, 2 and 3, sorry. 2 and 3 is approximately here. 3 and 6. 4 and 10. 5 and 15. And 6 and 21. Okay. So this is not a straight line. The first differences are not the same. So the first differences are not the same. That means that the area increases by different amounts each time the frame number increases by 1. So even though we're going up by 1 here, this is not consistent. It's going from 2 to 3 to 4 to 5 to 6. This relation is what we call non-linear. So let's look at first differences to determine whether relationships are linear. So for each table, Determine the first differences. So we're going to calculate that first. Then state whether the data represents a linear or nonlinear relationship. Explain how you know. So always subtract up. You want to make sure these are in order before subtracting, otherwise you're going to have to fix that up. 6 minus 0, 6, 12 minus 6 is 6, 18 minus 12 is 6, 24 minus 18 is 6. So if you look at these, they're all 6. That means it's linear because the first differences are the same. So let's look here. Again, these have to be in order. Okay. So you're going to do 4 minus 3 here. That's 1. 4.8 minus 4. That's 0.8. Oh, so they're already not the same, so this cannot be linear. But it says I need to calculate them, so I will do it all. And 6.2. So here, this is non-linear. Because the first differences are not the same. Okay, so if I look at the next one, again, I always want to check my independent variable, my x variable, or in this case, my s variable, but my independent. 0, 1, and then 1 to 3, and then 1 to 3 to 5, and then 5 to 6. So this is not going up consistently. This is going up by 1, then it goes up by 2, then it goes up by 2 again, then it goes up by 2 again. They've oh, sorry, by 1. So they've tricked us a little bit. So even when I calculate my first differences, if they're the same, this still isn't going to graph as linear because the graph is going to go, it's going to jump by 2 and 1s. So it's not consistent. So if I look, 20 minus 15, it's 5. 25 minus 20 is 5. So here I've gone up by 1, and here I've gone up by 2, and yet they're both 5. So they've really tricked me. So this is not going to be linear as well. So again, always subtract up. So it's non-linear because the increase your it does not increase by the same amount each time. So if you look, again, when your x variable is inconsistent, your first differences are. So if you look at the graph, if you were to graph these, you're going to have some inconsistency. So let's go through some more examples. Example 3. The following table shows the money in the bank account when it was opened and the end of each of the following week. So account balance, the number of weeks, the account balance, okay. And there's a graph for us. So let's see what the instructions tell us to do. So determine the first differences. What do they represent? So let's see. This is the number of weeks that are going by, and this is the account balance. So if I were to calculate the first difference, these go up by 1 at each time. So every week, I'll find out what's happening to the bank account. So we always subtract from bottom to top. Oh, I'm going to find out I get a negative answer here. So that tells me that money's being taken out of the account. That means this graph is going to be going down. Okay, so let's see. This is going to be the number of weeks because that's our independent. And this is going to be the account balance. Let's see. 0 weeks, account balance 200. 1 week it's 175. 2 is 150. 3 is 125. And 4 is 100. So it's pretty linear. So determine, we did that. What do the first reference? So it tells us that the first differences tell us that every week $25 is being taken out. We know it's taken out because it's a negative. This is a linear relationship because the first differences are the same. Okay. And then we've already graphed up. graph, describe the pattern. The pattern shows that as the number of weeks increase, then the money in the bank decreases. So if you look at the graph, you'll see a downward. So as the number of weeks increases, the money in the bank account decreases. Okay. How much is in the bank after 6 weeks? So we can predict that by just keep following the pattern. So go down one more for 25 for 5 weeks, and then on 5 weeks, or we could have just connected the dots with a line, and we'll know that at 6 weeks there is, so follow the graph, 6 weeks there is $50 in the bank. So let's summarize. The first differences are the change in the dependent value, or Y value, sometimes we refer to, for any relationship. First differences for relations. The first differences for linear relations are always the same, so they have to equal. For first difference for nonlinear relationships, then the first difference for nonlinear relationships are not the same. If the first differences are positive, the relation has a positive correlation. If the first differences are negative, the relation has a negative correlation. So again, you can look at if it's positive, that means it's going up, and if it's negative, that means it's going down. Okay, and we've already looked at correlations in previous videos. So just another way of determining correlations, first differences. And that's it for this lesson.